So today we're finally going to review the Ecoflow Delta, and a lot of people want to know if this is a good standalone solar power system. It has literally every feature that we want. It has a great output, a great input, lots of safety features. But before we do the review, I want you guys to understand the frustration that I've had with this company so far. This unit is sponsored. They contacted me and they sent it out. But I'm an original pledger for the original Kickstarter campaign. I put my money down about 7 months ago or whenever it started, and I was waiting to get it in mid-December. It is Christmas and I still have not received the unit that I paid for with my own cash. I have only received the sponsor unit. Also, this sponsored unit came a little late. They contacted me after they gave it to all these other bigger YouTubers. So I really do not like when companies do that. And the marketing team is a little slow. I contacted them months ago, or I tried to, and I never got a single response back. I tried like 3 different times. Also, in Amazon reviews for other Ecoflow products, there is horrible customer support and service. You can look up the reviews yourself. So before I even open up this box, I have a bad taste in my mouth with Ecoflow. I'm surprised that they didn't respond to any of my messages or calls. And at the very last minute, then they send me out a sponsored unit, and I still don't have the original one that I paid for with my own money. So let's move on to the review. Let's see if this is actually a good unit that's worth our time. And I'm actually pretty excited because this thing has insane charging capabilities from an AC outlet. And the first thing you see when you open it, it says, keep this box, enjoy the 24-month warranty, and support at ecoflow.com. But I don't know if I should trust this with all the complaints I've seen on Amazon. Oh, wow. This is fancy. And the carrying case and the packaging it comes with is really nice, but I don't really care about packaging like other YouTubers. I care about the performance of the product. So it actually has a very impressive build quality. I was not expecting that. In the pictures, it looks like a cheap toy, but it looks really nice in person. Like, this is a very durable nylon. So the total weight is 30.8 pounds, which is pretty good considering the output and battery size. And there are tacky stickers all over this thing. And the Delta comes with some cables. So first we have a cigarette lighter to XT60 charge cable, so you can charge with your car's alternator. And you have an XT60 to MC4, but these wires are very small. You guys, this is a 14 gauge wire. That's pretty pitiful. So yeah, you're not going to be parallel connecting your panels, but I don't think the input limit voltage is much more than 60 volts, so that's not that great. But I'm not sure what size the total array is, so I'm sure it's spec'd accordingly, so we'll find out in a second. Then we have a cigarette lighter to car clamps, and these are pretty cheap feeling. And then we have an AC input cable. And this is the front of the Ecoflow Delta. You have a screen that tells you stats about the battery and the inverter and what's going in and out of the battery. And then down here we have DC outputs that are USB-C and fast charge USB 3.0. And you have an on and off button for the entire system. And if you want to turn on these USBs, you press right here and it's on. But check out this screen, you guys. This thing is incredible. I've been testing it for the last hour and I love it. We have a state of charge indicator that tells us a percent and a blue graphic to depict how much power we have left. Next, we have an input and an output for the watts. So whether you have an AC or a solar charge controller, it will tell you how many watts are going into the Ecoflow Delta and how many watts are going out through the inverter and the DC outputs. And then over here, we have a net loss or gain meter. And it tells you how many hours we can power the load for. If you have inputs and outputs, it will take the net loss or gain and it will tell you how many hours you can power it for. You also have safety notifications on the top right. You have charge sources on the bottom. So this is a very quick, fast, easy to look at meter, and it tells you everything you need to know. And on this side, we have the inputs. And we have an AC input for a cord that connects to a wall adapter, and this has a circuit breaker with 20 amps max. So you could push a lot of power into this. And then we have a 65 volt 10 amp max XT60 connector. This is where you charge the cigarette lighter adapter or a solar panel or solar panel array, but you cannot exceed 65 volts or 10 amps. So you're probably not going to put any solar panels in parallel, and we're going to get to that later. And we have 6 AC outlets with a max output of 1800 watts and a max surge of 3300 watts. And you can turn these on by pressing this button. And you have a white light and some fans come on. And at the bottom, we have a cigarette lighter adapter. So let's check what the voltage is. And we have 13.6 volts. So this is a regulated output, you guys. This is awesome. That means that you can run your 12-volt appliances without a problem, unlike a lot of other generators on the market that have an unregulated output. So they did a great job with this. You could actually power a DC refrigerator with this no problem with solar power. So far it's actually very impressive. Now we need to test it. So the first thing we're going to test is the rate at which it charges with AC power. Oh wow guys, it's charging fast. We're already at 500 watts. You guys, it's charging at 1200 watts now. 1222 watts. I guess it takes some time for the cooling system to start kicking into overdrive mode. But yeah, we are charging very fast. This is like 10 times faster than most other solar generators on the market. That's really incredible, actually. Literally, it takes multiple days to charge a Goalzero, and this can do it in 1 to 2 hours. That is insane. So let's do a quick comparison. The Bluetti can charge at 168 watts. The Goalzero with their new upgraded fast charge unit does 300 watts. The Ecoflow Delta does 1222 watts, which makes it perfect for like weekend travelers. If you want to throw this in the back of your truck or van or RV and you want to charge it up really quick the night before, you don't have to wait multiple days now. You can just get one of these and it charges in a couple hours. That's incredible. So this thing is pulling as much as a microwave right now. This is a lot of power to be pushing into this small of a battery pack. Some people might argue that this much heat created by a fast charge rate will degrade the batteries. And it will, but it's not that bad. Most of these batteries are made to handle a 1C charge rate. So charging it in 1 to 2 hours is totally fine and healthy for these batteries, for this chemistry. A lot of people get freaked out with like Teslas and they're like, is supercharging bad for my car? And as long as it takes about 1 hour to charge, you're fine. All NMC chemistry variants can actually handle that charge rate just fine. And on the front of the unit, you can see the input in watts at the battery. So there is a shunt at the cells, and it is telling us how much power is going in, including the efficiency losses of the charger. So if we take this number and we divide it by the number on our watt meter, we'll have the charging efficiency. And the charge efficiency from our meters is giving us 86% efficiency, which is pretty good. That's standard. Now that it's charging, let's put a load on the inverter to make sure that you can charge and discharge at the same time. Some of the new Sookis, I forget how to say the name, you cannot do that. So we need to test that out real quick. We have a 1500 watt heat gun, so we're gonna crank it to the max just to see what happens. Okay, look it guys, 2300 watts going in and 1200. So it's actually bypassing the inverter right now and charging at the same time, which is a lot of power. 2200 watts is a lot to be pushing through this system. That's incredible. This thing can only handle 1800 watts, so I'm gonna have to plug it in just like this. You guys, this thing's a beast. We're already pushing 1000 watts, so let's add the heat gun. 2300 watts. So it will charge and discharge at the same time at a very fast rate. So while it's charging, I started reading the manual, and it shows a over temperature or under temperature warning on the screen. So if it's in a freezing cold environment, it will actually tell you. And the max amperage for the input is 20 amps, which is 2400 watts. So that was the maximum that we could draw while charging and bypassing the inverter for powering the heat gun. Whatever converter circuit they have on board is very beefy. It can push 2400 watts continuously. That's insane. Now let's see if the same is true for charging with the solar power system. Because this is a test, we're gonna just take off these MC4 adapters. And the solar cable is tinned copper, but man, I don't like 14 gauge wire. It should be like 12 or even 10 gauge. We're gonna bump the voltage up to 30 volts and 5 amps. So let's plug this in. And this power supply will mimic a large solar panel. We're charging at 136 watts, you guys. This is so cool. Wow, my power supply is freaking out right now. Oh wow, it's because it's tracking the power point. This has an MPPT. The voltage is not decreasing on the output. So this is pushing the maximum current that it can at this voltage. Because if this were to decrease, then that means that we would have a switching regulator. So this is a true MPPT, which is awesome. So check this out, guys. We have 1500 watts at the output, But when we had the AC input, it decreased to 1200 watts, even though this is a 1500 watt gun. So that means that when you have an AC input and output, it has a bypass. It bypasses the inverter, which is awesome. So let's give it a small load and see what happens. So we have 118 watts going in and 75 watts going out, so it will take 12 hours to recharge. This screen is really nice. I love this. It tells me the stats instantly, and if I add a load, this changes so quickly. I love that. Actually, let's do the AC and the solar at the same time and a load and see what happens. So with solar power and AC input, we have 1,100. Now let's turn on the heat gun. And check it out, only 1,200 watts. So that means the inverter is doing some of it when the AC input is connected. So there is some sort of bypass system. Wow, that is really cool actually. They pushed everything that they needed into this small little package. And going from 66% to 100, it says it will do it in 26 minutes, you guys. That is so fast. That is incredible. You know how much these things cost? These converter circuits for charging batteries? Like for even a Battleborn charger from Progressive Dynamics, it's like multiple hundreds of dollars. But this actually comes with it. And it's cheap. Man, this thing is completely destroying the Bluetti. And that's kind of sad because, you know, the Bluetti was so fun and nice and I liked it, but this is like another level. This is totally different. This is crazy. I mean, the Bluetti has a 1,000 watt inverter and this has an 1,800 watt. And it's like the same size. This doesn't have as large of a battery as the Bluetti, and I'm not sure what cells they're using, and I'm not sure if we can even open this thing up, but very impressive so far. Guys, it is fully charged and it took like less than an hour to go from 50 to 100. So incredible. So let's do the capacity test. So right now we're pulling 1,500 watts at the receptacle. And the battery capacity of this unit is 1,295, which gives us an inverter efficiency of 77%. That is not good. It should be 85, maybe 90%. That's kind of strange. But that was at a 1.1 C rate. So we're gonna redo the capacity test at a 0.2 C rate and see if we can hit a higher number. And now that we're charging it up again, we can put our watt meter on and see how many watts it takes to charge this unit. And after we have this unit of measurement and also the next capacity test at 0.2 C, we can measure the Coulombic efficiency, which will be kind of interesting because there is a lot of charge circuitry here. I mean, this is a very heavy duty, powerful charge circuit, so I want to see how efficient it is. So I just ran into an interesting problem. For the past 20 or 30 minutes, I've been trying to charge it and it will not allow it to charge because the last test has overheated it. So we have an over temperature warning and a battery warning, so it's not charging yet, but I'm going to give it some more time and see how long it takes till it starts charging. Guys, it's been over 35 minutes and it will not charge. It's still showing over temperatures. So after 2 hours of the fans on, it finally started charging. So yeah, the temperature regulation in these systems, I think they should have like a water-cooled system with a huge radiator on the side. But yeah, that took a long time. So if you're trying to like charge and discharge quickly, you're not going to be able to. You're going to have to wait about an hour or two between each cycle. But at least it's working. I thought it broke. I was getting scared. I also noticed that the charge rate has been reduced. Before we were getting 1,222 watts, but now we're only getting 640 watts, which is not nearly as fast. Now we're at 71% state of charge, and look, we are not charging at 1,200 watts. So I think the battery has to be very cold if you want to charge at that fast rate. So after about 4 hours, and not charging at all for the first 1 to 2 hours, and keeping under 600 watts, it is now fully charged. And it took 1.58 kilowatt hours to do that, so let's figure it out. And that gives us an 81% charge efficiency, but that's at a reduced rate. I wonder what it would be at if it was at 1200 watts. And if we want to calculate the round trip efficiency, we're going to take the power out at a 0.2 C rate. So this will take 5 hours. And it will give us an accurate assessment of the total capacity. Also, before we do this test though, I was reading the manual and I noticed that the lifespan of the battery, it states 800 cycles and then you'll have 60% capacity. Usually you'll have 80% capacity at like around 600 or 500 cycles for a Goalzero. So this is comparable to a Goalzero when it comes to the life cycle count. You'll still be able to use the battery after this point, but I think because this system is in such a small package and you are dealing with cooling issues and also the fast charge rate, you're going to have degradation more so than what I was thinking. So this is much, much lower than a lithium iron phosphate or a dedicated solar battery system where the battery is separated from the inverter. With this system, as you guys can tell from trying to charge it and being limited, you're just creating a lot of heat, and all of these safety systems have to throttle back the charge and discharge rate. And going by the life cycle count, if you want to cycle this thing constantly, this is not a good idea. So for a dedicated stationary solar power system, I would not use this. But if you're just using this system to go camping, you are fine. You can use this for years and years and you probably won't have a single issue. You can charge with solar and you probably won't even notice this degradation. But if you're cycling it once a day, you will absolutely notice this. I mean, let's just imagine this for a second. If you cycle it once a day for 3 years, you're going to be at 60% capacity. You're practically almost better off getting a lead acid battery. Not really, but that is just really bad. I mean, especially at 60% capacity. That's not that great. So it's great for camping and recreational use, but I do not think that it's good for a standalone solar power system. All right, now the next test, we're gonna do the discharge capacity test at 0.2 C rate. And for our test of 0.2 C, we'd have to do 259 watts, but the closest I can get is 276. So we're gonna let this run for 5 hours and come back and see what the results are. So that is a very bad result, you guys. We only produced 920 watt hours from a 1,295 watt hour pack. Also, if you guys remember previously when we were charging this up and it was charging slowly, we put 1.58 kilowatt hours into the battery. That means that the round trip efficiency is 58%. So if you put 100 watt hours in here, you'll get 58 watt hours out. Compare that to a high quality lithium iron phosphate system with a high efficiency inverter and a high efficiency battery charger. Typically you're going to get 79.38% round trip efficiency. So this is a very inefficient system. If you're trying to use this nonstop every day for solar power, I would say forget it. Whatever inverter and charger that they are using, even at a slow 0.2 C discharge rate, and at a slow charge rate, only 0.5 C, it still did horrible. We got a round trip efficiency of 58%. Where is all that power going? I know there's heat being generated, but that is not a good figure. And these meters are accurate to like 0.1 watts. So I've done multiple tests with multiple inverters with this unit, and it gives me good results every time. Something that I think might have happened is that it did not charge itself all the way, even though it said 100%. The reason I thought it was fully charged is that it said 100% and then the charging wattage dropped to 0. So I thought, okay, the battery is fully charged. But I think you need to top it off over a couple hours with an absorption to get like that last 10%. And with this speed charger, it might say, oh, one of the cells is really high, we're going to stop charging, and it cuts it to 0. But I don't think all the packs of cells were charged up all the way with the speed charge method. It might be different with solar, but I don't even have enough solar right now with winter to find out. So, I don't know, that was a pretty big bummer. 0.58 is not good, and I do these tests all the time. It should have done better than that. And if you think something I did in this test was wrong, please let me know. Now let's add another test. This battery was discharged at a 0.2 C rate, so I don't think we're in an over temperature territory. So let's try charging it again and see if we got the over temperature warning that we did last time. And it's actually charging within seconds, so that's a very good sign. But it's only charging at 117 watts. So I think it throttles it if the temperature is even moderately warm. Like, this thing is not warm, but it really reduces it. It's not doing 1,200. These cells need to be super cold to be able to pull off that fast charge rate. And it's at a low state of charge, so internal resistance is low, so it should be able to push as much power as it can. But it's not. We're only getting 116, 117. It's pretty slow. Alright, so it just increased the charging rate finally. Jeez. So the performance of this unit really depends on the temperature and how you are using it. If you want to get the full rated capacity for the input or the output, you need the temperature just perfect. So after doing multiple tests and technical discussion on how this thing works, we're going to talk about a general overview on if you should buy this and what you're getting into and some of the downsides of buying this unit. And unlike the previous discussion and testing, this will be for lay people. You do not need to really understand how this works to understand these pros and cons. So this will be a beginner-friendly part of this video. So first off, it has a very fast charge rate capability when you plug this into an AC outlet, but it is very temperature dependent. In my testing, if I use the inverter and this unit gets warm, it will throttle the charge rate. This has a very great power capability, and you can push a lot of power in and a lot of power out, but the moment it warms up, it will throttle the charge rate. But it is still 10 times faster than everything else on the market, so it's pretty incredible. Even at the slowest charge rate that we measured, it was still faster than everything else on the market. So that was a very good benefit in this unit. Next benefit is that it's cheap. It is cheaper than everything else out there. This is $1,100 and it beats everything for the battery size, the inverter size, almost every regard. Also, the build quality is incredible. I thought that this thing looked like a toy in the pictures, and I have not seen any of the Ecoflow products, and I've seen some of the battery reviews, but this looks great. This is very solid, durable nylon, and I might do a breakdown video, but I really don't want to. I want to actually test this more, especially during the summer months. This thing is really strong and it looks great, so I do like that. Next, the inverter output is 1800 watts for all of the receptacles combined and 3300 watts for surge. So that is incredible. Anything that you plug into a house outlet rated for 110 volts should be powered just fine with this. And that's with the continuous load. We put a 1500 watt hour heat gun on here and it powered it for the whole duration of the test. We actually got the maximal capacity at a high C rate discharge test. So also there's a good warranty and there's a battery specific warranty, but I've seen a lot of battery reviews on Amazon for Ecoflow's customer service and repairs. And in my experience, after emailing them multiple times, they are very slow to respond or they don't respond at all. So it might have a good warranty, but I really don't know this company enough to know if they will actually stand by their warranty. So only time will tell. The next benefit is it's UL listed and safety certified. UL certification for anything with a lithium-ion battery you absolutely want to have. So you will know that this will not catch on fire while you're charging it unattended. You typically always want to watch batteries when they are charging, especially at a fast charge rate, but you shouldn't have to worry because we have good safety certifications on this unit. So that's a huge benefit. And a lot of other solar generators on the market do not have safety certification. The next benefit is that the 12 volt output is regulated and you can push 8 amps. So for RV and van dwellers that want to power a DC fridge from solar power, you can use this as your battery. It will power it just fine. It's at 13.6 volts, which is really good. The Bluetti has a regulated output, but it's 12.3 volts. And most of the other ones on the market, including the Goalzero, are not regulated at all. And with the Goalzero, you have to spend another $50 or something. And the Goalzero is so much more overpriced than this thing. I just have to drive that point home. This is cheaper than the Bluetti. It's cheaper than almost everything else out there. And it comes with all the cables and adapters, which is a huge benefit as well. The next thing I like is it shows the high and low temperature safety protection on the screen, and it has a really cool screen, but I noticed from testing that I think that this screen is using voltage for state of charge, and that is not good. It doesn't seem like a true coulometer, and I could be wrong, but when I was doing the last capacity test, as it was getting lower and lower, this thing was giving me weird numbers. It would go from 1% to 3%. It said it had 3 minutes left, but then it ran for another 15 minutes. So I don't really trust this screen readout, and when I first used it, it was very useful and it seemed very accurate, but it seems a little finicky for the state of charge aspect of it. But the watt meter seems good, and that's all what most people care about, but I would like to see a better state of charge monitor. It shouldn't have given me those weird numbers jumping up and down at the end of a capacity test. That's unacceptable. Now that we've gone over the pros, let's go over the cons. So the first downside that I found in testing is that the over temperature limit throttled my charge rate. Okay, so whenever this thing is moderately warm from even a small or a large load test, it will throttle the charge rate. And when we have a large load test, I couldn't charge this for 2 hours after I did the test because it was so hot. So it makes sense because you have so many circuit boards and temperature sensors, and it's throttling it so that nothing gets hurt inside. But if you're trying to charge and discharge this thing every couple hours, you're just not going to be able to do it. It will go into protection mode and you will not be able to cycle that fast. The next con is that the battery is rated for 800 cycles to 60% capacity. So if you're trying to use this unit as a standalone solar power system for daily cycling use, I would say forget it. I mean, that's almost as bad as an AGM lead acid. Just think, in 3 years' time, you're going to be at 60% capacity if you're using it for solar power every single day. Or if you do it multiple times per day because it can charge up so quickly, in about 3 years, you're going to be looking at a bad time right here. 60% capacity is not good. The next downside is the round trip efficiency in my test was 58%. It should be at least 70%. So if you're looking for an efficient solution for putting power in and taking power out, and you have a limited solar panel array and you are depending your life on this solar power system, I would not use this. Absolutely not. Next, we are using NMC variants. So it's not lithium iron phosphate. So 500 to 1,000 cycles is the maximum that you'll get with this chemistry. If we have lithium iron phosphate, we're looking at 2,000 to 5,000 cycles, and that's to 80%. So if you want a standalone system that will last a very long time, you're going to have to build it yourself because no one is making one of these small solar generator standalone systems with lithium iron phosphate. The next downside is you can only connect a maximum of 400 watts of solar panel power. We have taken the Bluetti and it has current limiting and overvoltage protection, and we have pushed 600 watts. Also, when you read the manual, it states that it recommends having a serial connection. It says recommended with 3 110 watt solar panels with an open circuit voltage of 21.6. Do not add a fourth panel because it will hit the overvoltage protection. And it says that it actually has overvoltage protection, and it says that you can actually parallel connect 2 strings, so there is some form of current limiting, and there's also a limit for the overvoltage. But I would not trust that. After reading that, I would stick with 300 watts of solar panel power. And if you want, you can overpanel it and put them in parallel. But again, you have 14 gauge wire going into the Ecoflow Delta. If you connect 600 watts of panels, okay, and you parallel them, even current limiting, you're pushing this thing to the max. So it will only accept 10 amps and that 14 gauge wire can handle it. But if you're trying to run that wire pretty far, that just seems like a bad idea. I would never buy this many solar panels if I can only use 10 amps from it at the nominal voltage of these panels. That's just crazy. I think that that would be a waste of money. But if you have only 300 watts of panels, it should work perfectly fine with this. And considering the size of battery, it would charge up very quickly. For some of you guys out there that want to push like 400 or 500 watts, this is not for you, in my opinion. The next downside was the inefficient charging and discharging. I wrote this when I did the initial charging efficiency test because I didn't think it was that great. But when I did the round trip efficiency and we found it was only 58%, that was a big red flag. So overall, what should you guys think? If you are using this on the weekends and you plan to use it once a week in some light solar charging and you want to use it with camping with like a CPAP machine, this is perfect. You can charge it up the night before in a couple of hours if the batteries are cold. You can use it all weekend. You can power a cooler, a small fridge. You can power your laptop. But I absolutely cannot recommend this unit for daily solar power system use. If you want to depend on this unit for cycling every day, I would say forget it. You need to build your own system or pay someone to build a system with the lithium iron phosphate battery. If you're pushing like 10 to 20 years and you want to use it every day in like a cabin or a small home, do not use this. You could actually chain these together and have a lower C rate and keep the batteries cold, and maybe you will get maybe 1,000 to 2,000 cycles with limited degradation. But with how it's designed and the temperature control system and how it throttles it, if you're using it how it's advertised with a fast charge rate, you are going to hit the charge cycle life that we talked about of only 800. So for a standalone system, do not use it. But if you're using it on the weekends for camping, this thing is perfect and it's super cheap. And I'm going to actually recommend it because it did pass all of the tests. It is highly inefficient, okay, and we went over every single downside, and there is degradation that's significant. But there are lots and lots of people that want a simple, easy to use, fast charge battery. Not everybody needs to cycle every single day. So if you fit that category, this unit is for you. So that was a lot to talk about, but I hope this video made sense. If you disagree with anything that I said or any of my testing or any of the logic that led to my conclusions, please let me know in the comment section below. And I also want you guys to understand that if you buy this thing and you have any issues at all, okay, with customer service or support, email me or post it on my forum so other people can know. I do not know this company that well, and I've had a troubling time with contacting them, and so have other people. So if you guys have any problems with these units, let me know. We are going to test this one for the next couple months, and I'm going to see if I like it more or less, or if I run into more problems. But I think we thoroughly tested it enough, and it has a great output, and you can charge very quickly. So I think this will make people happy. Anyways, I'm going to keep talking and talking. So thank you so much for watching. I'll talk to you guys later. Bye.